Divide by 0 is A. Hardware interrupt, software interrupt, both A and B, none of these. Actually, the interrupts we can have if we take external interrupt and internal interrupt. External interrupt is not based upon the program being executed. Internal interrupt is based on the program being executed. For example, if the same program is executed again, in the same place we may get the interrupt. That is called internal interrupt, like divide by 0 interrupt, or any other interrupts like stack overflow interrupt, register overflow interrupt. So these interrupts is a part of hardware interrupt. So divide by 0 is a hardware interrupt. Option A is the right option.
It is given that there are 253 people in the room, and we have to find the probability of the event in which no one else in the room shares your birthday. And if we ignore leap year, the number of days in the year would be 365. And your birthday can be any one of those 365 days. And if we remove your birthday from 365 days, the remaining days would be 364. So, for any person occurring birthday in these 364 days would be 364 by 365. So, for each and every person in the room, the probability would be same, 364 by 365. Why? Because they can share their birthdays, but they cannot share your birthday. So the required probability would be 364 into 365, so on up to 253. Why? Because total 253 people are there in the room. So the required probability is nothing but 364 by 365 whole power 253, which is option C. A relation and set of FDs are given, and we have to find the key for the relation. First of all, what is a key? A key is nothing but a set of attributes which uniquely identifies a particular row in that table. So how can we find a key if FD set is given? We have to find the combination of attributes, the closure of which derives each and every attribute in the table, in the given table. So let us find the closure of AB. AB plus gives C. So AB plus gives AB and C. Can we derive other attributes from AB? No. So AB plus gives ABC. Let us check with CD. So CD plus gives CD. From CD we'll be getting E. From DE, so we have DE. So from DE we'll be getting B. So here A is missing. So CD is not a key. Let us check with DE. So DE plus DE closure is nothing but DE, and from DE we'll be getting B. So it is stopped here only. We cannot determine the remaining attributes from DE. So let us check. Let us find the closure of ABD. So ABD gives ABD. From AB we'll be getting C. So from AB we'll be getting C. From CD we'll be getting E. So from CD we'll be getting E. So from ABD we can derive all the attributes of the table. All the attributes of the table, that is A, B, C, D and E. Hence, here ABD will be the key, which is option B.
Question is, a circuit gives output 0 for each input bit unless the following condition meets. Either it gets consecutive 0 or consecutive 1. After that its output is 1 always. How many states are required to implement it? See, after going through the question, we're going to understand that it is a kind of a pattern detector. Means, suppose it is a pattern detector whose outputs are 2. Either it is 0, either it is 1. Input is a sequence of sequence. Means it is kind of a 0 0 0 1 1 0 1. It is some kind of a bit stream is coming as an input to the pattern detector. It has to detect whether it is, if two successive zeros are happening, then it has to produce 1. Two successive ones are happening at the input, it has to give 1 output. If it is not satisfying this condition, it has to give the 0. Means if suppose first bit is 0, the next bit can be 0 or 1. If it is 0 0, then it has to produce output equals to 1. If it is 0 1, the output must be equals to 0. Suppose after getting 1, if it is 1 as a bit, the next bit could be 1 0. If it is 1, the output has to be 1. If it is 0, output must be 0. So that means how many possible combinations are there? Either 0 0 are possible, 0 1 possible, 1 1 possible, 1 0. Means we can implement it with 4 states. That means suppose whenever it is in 0 state, suppose it is implemented with a Miller machine. Means every state, means next state depends upon the present state as well as the input. So suppose if it is 0 0 is happening, means 0 is the bit in the sequence, 0 is the output. This is written in the form of 0 by 0. Now in the S1 state, so next bit is, if it is 0, if it is 0, it gives output 1 because two consecutive zeros are happening. It goes to state S3. Suppose if after 0, instead of 0 is happening, if it is 1 is happening, then 1 0. Suppose this is, I am indicating it with S2. 0 1. Now if the next bit is 1, it is going to state 3, which is 1 by 1. The first bit could be start with 1. So if it is 1, this. If it is after first one, if it is 0, it is going to reach here, that is 0 by 0. Next bit is this. If it is after entering into the state 3, if any further zeros or ones are going to occur in a sequence, then the state machine is going to stay in the state 3 itself, like this. That is, if it is after getting two consecutive zeros, if it is going to get a third, means one more 0 in the pattern, so it is going to stay in the state 1 and it will give the 1 as the output. See, after getting the two ones as a consecutive ones, see, after entering into the state 3, it is going to stay in the state 3 itself. If one more 1 is going to enter into the pattern, that is 1 by 1. Hence it requires 4 states to implement this pattern detector, that is option B is correct.